Welcome, everyone. I'm very happy to be here to present about a topic that I'm very passionate about, which is how to get started with the new generation of user interfaces and user experiences, not in the 2D environment, but in 3D environment with the Unity and augmented virtual reality. But I'm very happy to be here again at DDD, and a particular thank you to all the sponsors and everyone that was able to set up these events. There are some fantastic sessions, and if you have the opportunity, just donate with the fundraising which is in place for the National Museum of Computing, and share the love on the social channels with the hashtag DDD 2020 and Developer Day. But the first introduction about myself. My name is Davide. I live in London and I work as a senior software engineer. I started working with this generation of apps in 2017, initially with the HoloLens and augmented reality devices, and lately spanning a larger spectrum of devices, including Oculus Quest or Rift or HTC Vive or the Windows Mixed Reality headsets. In the past, I've been awarded 5-time Microsoft MVP for my contribution to the community. And I like share my adventures in coding on my blog or on GitHub or on Twitter. More details later, but let's see the agenda for the session of today. We will start by introducing this concept of a mixed reality and how it relates with augmented and virtual reality. And then we will introduce some programming best practices and introductions to SDKs like the Steam VR, which are quite good for start prototyping quick on virtual reality apps. But given these virtual reality apps, we then want to start to adding much more natural form of interactions like vocal commands or hand tracking, and then moving to the other extreme of the spectrum with augmented reality applications. Let's start for introducing this concept of mixed reality. Mixed reality is the blending of two worlds: the physical reality, where we live every day, where we can touch things, where we can feel stuff, and the virtual reality, which is completely generated by a PC. In this blending of worlds is where the magic happens, because it is when we are able to augment our environment with holograms of 3D objects, where we can, for instance, try a new type of furniture, or we can just pin some screen on the environment to watch TV, for instance. And to better understand the various types of devices that we can find for these types of application, I like to relate to this physical digital reality spectrum, which is a concept introduced in 1994 by Paul Mingram and Fumio Kishino in the paper A Taxonomy of Mixed Reality Visual Displays. In this paper, we can analyze all the different possible devices from the digital reality one extreme to the physical reality. For instance, a device like this one, which is an Oculus Quest, is completely occluded. So the particularity here is that you cannot see through. And so these devices will be part of the digital reality way of doing application, where we will have to generate a 3D world for the user, and we will add manipulation interaction in the 3D world. Example, the devices apart from Oculus Quest, the well-known Oculus Rift or HTC Vive, Cosmos, or the Vario VR3. While we move through this spectrum, we can find a lot of other devices. And when we move towards the physical reality, we can categorize those one like HoloLens or RealWear HMT1 or Lynx R that are those devices where you can see through. So you would not need to generate a full 3D environment usually, because you can see through in this environment, but you can position some 3D objects called holograms that can be imported from software like 3D Studio or Blender. But why mixed reality? This is a question that I often ask myself when studying this cool technology. I think that VR, AR as a next computing platform, we will see a lot moving from 2D to 3D user interfaces, and interacting no more with a mouse or a keyboard, but with more advanced sensors. And it is estimated also a growth in this particular sector of technology. So some paper mentioned an 80 billion revenue by 2025, so there is also an economic opportunity. And most importantly, mixed reality is really revolutionizing a lot of sectors. Clearly, gaming is one of the first sectors that started to adopting these technologies because of the hardware requirements. You need a lot of powerful GPUs to render scenes on both eyes at the same time, 90 frames per second, for instance. So you need some powerful PCs. Usually, if you are a gamer, you have these devices already available, so you can easily start to enter this world. But also video entertainment, just to watch movies or 3D video in the 360 space. And different sectors also are starting to adopt virtual augmented reality for particular type of apps. I was recently studying how these apps are used also in healthcare, for instance, for studying the interaction between doctors and patients, or for curing some phobias, for instance. So that's really a range of activities where we can adopt these technologies. And education is particularly important. Take, for example, the opportunity to train employees in virtual or mixed reality, which was something that I encountered in the past as a request. So a lot of sectors, a lot of opportunities over there, but let's see what we need to do for creating a virtual reality or augmented reality experience. My background as a 2D developer, .NET C# mainly, initially when I started approaching this type of apps, I immediately noticed that it's a completely different paradigm. And I was quite lucky to find this concept of illusions that was introduced by Professor Mel Slater of University of Barcelona. And he mentioned that for designing a great VR experience, you need to provide three types of illusion: the place illusion, the plausibility illusion, and the embodiment illusion. For place illusion, we require to have a proper environment. So, for instance, if I am designing a game that is in a mysterious dungeon, I need to provide a proper environment with a proper scaling and everything else. But it is not sufficient, because when you are in this environment but nothing is happening, clearly something is wrong and you immediately notice it. So you're missing this feeling of presence. And you need to introduce some additional stuff. And one of those is also the plausibility illusion mechanism. This plausibility is the fact that the environment needs to interact with you. So if there is a virtual agent in the world, this virtual agent should look at you or interact with you if you are in a virtual environment. And the third one is the embodiment. Give a representation of the body in this virtual environment. So the first experiments of embodiment that I did were quite poor, and I was trying to represent a full body for myself into the 3D virtual environment, and then was breaking this sense of immersion because I understood that that was not my body when I was in the virtual experience. So other implementation like this one from Oculus, which is just showing the hands, for instance, is more than sufficient for providing this embodiment illusion. And when I was trying to represent the plausibility illusion, I decided to do a quick prototype using a virtual character that was looking around. And you can see here in the example how the virtual character is looking at the camera that I generated with the Unity in this particular example. Just the sense and the movement of the virtual character looking at my eyes was sufficient to give me the impression that I was the environment. So embodiment illusion and plausibility illusion as very important design consideration when you want to create a virtual reality experience. Let's see how we can practically develop this stuff. In terms of development tools, I found that three main categories are game engines like Unity or Unreal Engine 4. These are software that enable to import models, 3D models generated in other packages like Blender, for instance, and apply some transformation to these objects like physics transformation or 3D transformation or transformation in like translation or rotations. When you have this game engine, usually you are able to create experiences very quickly and having the opportunity to iterate quite quickly and check prototypes and go into production quite soon, which is a bit different when you want to have more performance and better performance, like using APIs at a more lower level, like OpenGL or DirectX, Vulkan, that for sure require much more work from a development point of view. And clearly, JavaScript-related technologies are something really important for the future. WebVR or WebXR are growing a lot, and frameworks like A-Frame or Babylon.js are very good for writing 3D experiences in JavaScript, and I think we will hear for sure a lot more during the future. In terms of languages, C#.NET for Unity and C++ for Unreal Engine, and JavaScript for the one that I mentioned before. Clear when you have designed your experience in virtual reality and you start to interact, you understand that you don't have no more available a mouse or a keyboard, so you need to implement some different form of interactions. Form of interaction that are continuously studied every day and improved every day. And there are some basic ones that are recognized as good ones when you develop for VR, like gaze, gesture, or voice, and or the one that we have listed in this slide. So clearly, when you have this type of experiences, you can also take advantage of much more advanced form of interaction, like hand tracking or eye tracking. So there are a lot of more consideration that you need to do when developing these experiences. In particular for VR, when I started working on some small prototype, I identified this main form of interaction for interacting with objects and manipulating objects, which is by using just the motion controller, you can just select object and grab them and throw them, for instance. And this is the main form of interaction that I needed to implement in my prototypes. Clearly joined by the capability of being able to move in the environment, because if you are in a virtual environment, you are not able to move and to explore it, you are losing this sense of presence that we mentioned before. So in terms of locomotion, movement, you can use, for instance, teleportation, which is a very good way of providing this capability for the user, since it's not providing a lot of motion sickness, which is a particular consideration, very important to be done when designing this type of experiences, and enables you to move into your environment. So let's move now to Unity and see how to create a quick prototype with the virtual reality using the Steam VR plugin. So usually when I start a new app in Unity, you just create a new project over there, and you can specify different type of projects over here. And the 3D project is a very good starting point for VR apps, because we don't have rendering, particularly complex rendering pipelines or other types that could interfere with some headset at the moment, because they are still being improved for this type of application. So when you have created a new project, you can import some assets that are usually provided by Unity, we can start enabling our project for virtual reality. The first step is go to the build settings and select, in this case, decided to create a PC and Mac, a PC standalone build for Steam VR. And just selecting the player setting over there, and in XR plugin management, you can just enable the OpenVR, which can be done in Unity 2020 by firstly importing the OpenXR plugin that is available by Valve in GitHub. I will post the link later. When you have enabled the XR plugin management and enable OpenVR, you're pretty much ready to start the development on your VR app, because the project is ready for being deployed to the device. But clearly, we need to provide additional capabilities like the 2 cameras for the eyes or the opportunity to interact with objects. So in Unity, you can import the Steam VR plugin using the Windows package, the Unity Package Manager, and going over there and selecting the Steam VR plugin. After importing the Steam VR plugin, we will find a Steam VR folder in our project, like here. The Steam VR project is containing all these prefabs and Unity scripts that you can use to enable your project for VR. For Steam VR, the most important one is the player prefab. When you get the player prefab into your project, I usually embed it in another game object that I call VR camera rig to group together all the stuff that is related to the player. You can find a lot of helper properties and helper objects in Unity and scripts that enable Steam VR to control the camera, control the collider in your experience, or control the 2 different motion for the hands, for instance. And it is ready to go for your deployment to the device. Once you have created the player, you can easily start to add the capabilities. So clearly, we mentioned before, there are 2 main capabilities: the locomotion and the interaction. So let's see how to implement locomotion using Steam VR. You can import the teleporting over there, prefab from the Steam VR plugin, and just drag it directly into your experience. I have already prepared here the solution, so we can move more quickly on this example. So the teleporting contains a lot of customization that you can do. For instance, changing the color for doing the teleportation, for the X-rays, and the visual indicator where the teleporting will be performed, etc., etc. And after adding the teleporting prefabs, I decided to add a Unity 3D plane into my ground, and then adding a teleport area script, which is available in the Steam VR plugin. This teleport area script will enable teleporting on this area, which is highlighted in the scene right now. And just to add additional stuff, I added also a teleport point, which is particularly useful if you want to be teleported to a particular location in your experience. Done this, you are ready to test the teleportation your experience. But usually when you teleport around your environment, you want also some opportunity to visit your environment, so to rotate your camera on the left, on the right, at 360 degrees in order to visit all your environment. So I prepared a small script here, which I call the rotate player. So we can see also how to implement a quick mono behavior that capture the input from the controller on the joystick, and if the joystick is left, is rotating for some degrees on the y-axis on the left, and otherwise on the other direction on the y-axis. To do that, I just created an input source object, which is defined as the Steam VR input sources in the Steam VR plugin, and listening to this event, I can then capture the value of the axis, which is entering the controller, and then trigger a transformation on the right or on the left by simply apply a rotation on the transform object of the player, which is quite simple, but will enable this additional user experience for the user. So we added the teleportation, we added some rotation, a snap turning into our experience. Let's see how to add interaction, because if there are some objects in your environment, you really want also to start interacting with them. And here we have a small table with some object over there. So let's choose an example here, and the hat, for instance. Let's enable this hat for interactions. You can just search for the interactable scripts in the Steam VR plugin and drag the interactable script directly on your object, and it's all ready for being manipulated by the user in your virtual experience. So if we run now our experience in the headset, I prepared a video here just to not give too much motion sickness to the audience when working with these virtual reality devices. You can see when we play this scene in the headset, this was a Windows mixed reality headset where I implemented this simple scene. You can just rotate using the snap turn functionality that we implemented before, and then we can just look around and we can perform teleportation into the environment, which is, as described before, a good way to not provide motion sickness to the user. And we can visit our environment, we can go near the workbench and go to the teleport point we defined before and manipulate some objects and also throw them using the throwable script that I added. So that's pretty amazing stuff, in my opinion. You can get started with VR development in just a matter of minutes, having something working in your headset and to try out your experience. But then when I designed this first iteration of virtual reality, I was missing more natural form of interaction. And I thought, what about if we wanted to add the voice input for showing a help screen or for giving instruction to our player? And I started analyzing the different options, and the easiest option was to use the Unity keyword recognizer. And I started using this before moving to more advanced form interaction like natural language understanding available in cognitive services, for instance. So for adding vocal commands, use a keyword recognizer in Unity is quite simple. Just define a list of words that you want to be recognized in your experience. Then instantiate an object of type keyboard recognizer, passing this array of words. And then when one of these words is recognized, you can just do some actions into the on-phrase recognized event, which is quite simple. So for instance, in this example, I decided to show a UI for showing the frame per second that my experience was going on when the user was saying the words show FPS. So you can see when the phrase gets recognized, you can verify which word is being recognized and then activate or not the option if needed. But what about if you want to implement a natural language processing? So what about if you want to provide help to the user? And the help can be clearly asked with different keywords like help or what should I do? And clearly, it's a complex problem. And for solving this problem, we can take advantage of the intelligent cloud of cognitive services present in Azure, for instance, by passing to them some input that has been captured to the microphone and process this input in the cloud via machine learning artificial intelligence algorithm, return some intents that have been recognized to the user. So I started by creating a simple app for language understanding in LUIS on cognitive servicing using the Azure portal. After doing that, I got clearly a key and endpoint that was generated, and created a simple app on cognitive services so that I can capture all of these. And as part of this app, I wanted to be recognized an intent of type help. So I used the utilities.help intent that is already defined, and provided some training data for this model, like phrases, who can help me, or why should I do, train the model in Azure, and then publish the endpoint. When I have this endpoint ready, I can start using it in my Unity experience. This time, not using the keyword recognizer, but using the dictation recognizer. The dictation recognizer is not listening only for some specific words, but for everything which is capturing the microphone. So I can just grab the string, which is being recognized by the microphone, and then send this string to the LUIS cognitive services, and then get a result back. So which is just an HTTP web request call to the cognitive services bypassing the query string. In this case, I decided that when the tolerance was greater than 65%, then my input was good. So the help event was recognized correctly. And then I decided to handle help just showing a small message box to the user. And then I put it all together by creating a simple game to demonstrate how, by just adding simple interactions and locomotion using SteamVR, we can provide already experiences for a full game for the user, and also enhanced by voice recognition performed using the keyword recognizer or the LUIS cognitive services. So you can see I can just navigate the environment, I can manipulate stuff, I can grab objects, I can continue to move using the cognitive services manipulation that were previously recognized by my language understanding, and then via teleportation move on different environments, collect other objects, and so on. And that was pretty cool, but what about the possibility of deploying this experience not only on a single headset or targeting multiple headsets? So I decided to write a small script that is using the XR device APIs of Unity to recognize the headset that is currently running the experience on, and adapting some small capabilities depending on the headset that it is executed. Sometimes you have some small fine-tuning that you need to be doing when the experience is running on a Oculus or on a HTC Vive or on a Windows mixed reality device. So I found these quite easy to use and pretty simple to implement. But the most important stuff that was clearly evident while developing this experience was performance. So if you're not reaching a good performance, you're giving motion sickness. So for instance, if you're running this experience on an Oculus Rift or an HTC Vive, you need to run this experience at 90 frames per second, or 72 frames per second if you're running on an Oculus Quest, or 60 frames per second in mobile devices like HoloLens. I found particularly useful a script that I wrote for checking if the objects that are not moving are marked as static or not as an option in Unity. So if an object is not moving, as a performance consideration, mark it as static, so you can improve a lot the performance of your experience. So I wrote this small script is finding all the objects that are not marked as static, and you can then adapt your target for marking or not marking them, which is quite useful. And the second one is lighting. Lighting is very, very expensive in virtual reality applications. So if you disable real-time lighting, the performance are much better. So very good tip that was talked to me while I was doing the Unity and the Udacity, virtual reality nano degree, was about disabling the global illumination using baked lights. And this one is very important. Avoid not performant code at runtime. For instance, debug.log is very expensive at runtime, so should not be called into the update method of the mono behavior. But other techniques like caching strings, like you can see in this example, I create a string of name key tag string, and I am caching it as a private variable. This is also important in Unity apps. And the get component call to be done only on the awake method and not on the update method is another way of avoiding performance degradation when you are running your experience. So we started looking a lot at virtual reality and the interaction that are not natural, like interactivity or locomotion, and we started moving more natural form of interaction using voice. But what about not using anymore the controllers and using the hands, which is a capability that now is being introduced in devices like Quest, that like HoloLens now can track your hands and your fingers in their experience, so you don't need to use the controller, which is very natural. Because, for instance, I remember when initially HoloLens 1 was released, and it was not simple to tell user that the tap gesture was for selecting object. Now with the hand tracking, it's possible to give more natural way of interacting with the environment to your users, like for manipulating things or moving around, etc. And a very good starting point for implementing hands interaction is the mixed reality toolkit for Unity, which was initially created for the HoloLens device, but now is available and enabled to target not only HoloLens, but all the different devices in the spectrum. And when I was playing with the mixed reality toolkit, I was just testing hand interaction in an Oculus Quest using the default scene which is provided. So you see here that you are not using the controller, you're using your hands for interacting with the environment, interacting with the sliders, or touching things, and provide manipulations like this one, two hands manipulatable scripts that enable to size your 3D object, sort of pinch and zoom, which is available with the mobile devices, but on the 3D space. Or you can control with your finger some 3D object, or interact with the buttons, or interact with object at distance, like this way, and apply these two hands manipulations also to distant objects that are not near you, but distance, which is particularly important when you're writing this type of app. And imagine here the various possibility that you can have with these interactions for, I don't know, exploring some devices that otherwise in the physical world would be very expensive to be done, right? So it opens a new category of applications. And we are slowly moving through. Remember, previously we mentioned the digital and virtual reality spectrum from the physical reality to the virtual reality. We are moving towards now the physical reality. So how to develop for augmented reality apps. And Mixed Reality Toolkit is a fantastic tool. And when I was using it initially for trying application on HoloLens, I immediately noticed that when you're writing apps for augmented reality, you have a lot of other considerations that you needed to do, because you have a lot of other sensors. You have eye tracking, you have hand tracking, you have depth cameras or normal cameras and gyroscopes and everything else. So the type of experiences are a bit different from the one that we saw before for virtual reality. I started to create the Hello World app in augmented reality, which is just get an image from the camera, get this image sent to the cognitive services or any other machine learning power service for recognized computer vision objects, and then get this result back to my HoloLens device. And for doing that, as we did before for the speech, I created a new computer vision application in the Azure portal, and I tested quickly that this computer vision endpoint was working by creating a UWP app for generating a library that I could then reuse in my HoloLens app. When I have this library ready, I can just test quickly that the cognitive services endpoint is returning the correct results. For instance, here I got a quick photo of the Microsoft headquarters in Reading, and you can see how cognitive services can get a very good confidence when recognizing objects. And then I just plugged everything in a Unity project with the mixed reality toolkit, and that in the initial version was called the Holo toolkit. You saw here, I put a quick text label just to indicate what's the output of my recognition. And then with techniques that we previously mentioned for capturing voice, asking words like recognize to the device for triggering this cognitive services recognition. And you can see this is the experience running on the HoloLens, when it's just recognizing that I am looking at a screen, which is a flat screen television, and can open a lot of other opportunities for the future. Think about when we will be able to miniaturize all these devices in normal glasses like this one. We will be able to create such experiences for, I don't know, for healthcare or helping visually impaired person, etc., which is pretty amazing. And we cannot limit our usage of cognitive services, but we can really go and use the full spectrum of services available in the Azure Mixed Reality services. Suppose, for instance, you want to render a big quantity of a polygon. Usually a virtual reality desktop headset can handle 1-2 million polys. So a good amount, but really not sufficient for some type of applications. Or a mobile device like HoloLens or Quest can handle clearly a lot less, like 100,000, 200,000. You cannot really on those devices render polygons or scenes like photogrammetry that requires, I don't know, 100 million poly per scene. So you need to take advantage of additional rendering solution like Azure Remote Rendering, perform the rendering in the cloud, and then capture the result on your device, and then use it in your mobile device. Or special anchors for marking location in the real world, not only in the virtual world, which requires a lot of computational power in terms of machine learning, etc., etc. Or object anchors for doing stuff which is anchored to the player itself. So to summarize the journey that we did, we covered a lot of stuff. We started by introducing mixed reality and this concept of illusion to design proper virtual reality applications. And then we started implementing a quick example using VR interaction and VR locomotion. And then we started moving versus the augmented reality side of stuff using vocal commands and hand tracking for the latest experiences with the mixed reality toolkit, with a glimpse of what we can do on augmented reality devices like HoloLens, like recognizing objects, and augmented additionally your experience using all the spectrum of mixed reality services like remote rendering or spatial anchors. And the key takeaways that I found while developing this application is very important to look at performance, because if your user is not able to use the app, because it's getting motion sickness, there is no way that we can ship a good quality app that the user is clearly adopting it. So check the performance early and often to avoid motion sickness, and this can be done also testing frequently using the target device. Particularly important is also to design properly the experience for maximizing the user immersion by applying the three types of illusion that we mentioned before: the place illusion, the plausibility illusion, and the embodiment illusion. And use cloud services to enhance the user experience is very important. Speech, visual anchors to provide this natural way of doing things to the user and to not create too much experience very difficult to use. And I would like to finish with a phrase from Arthur C. Clarke, Profile of the Future, that any sufficiently advanced technology is indistinguishable from magic, because when you try, this experience is magic. Thank you very much. I will publish the slides and the source code of the samples on my GitHub profile and my blog, which you can find here on the slides. And I am here for any questions. If there are no questions here, you can reach me on email or Twitter, because I am always happy to speak about these great technologies. Thank you very much.